Hi, welcome to Robojax. In this video we are going to build a digital clock from a kit that is sold on AliExpress and eBay, and this clock is built based on the microcontroller made by Amtel. The microcontroller is AT89C2051, and this is also known as C51. So very compact, and this is the completed version. It has two buttons and buzzer that you can turn it on and off, and we have the schematic diagram or full manual for this kit and the description, which you can download it from robojax.com. So let's get started. Actually, when I completed this project, I realized the audio was very bad with a lot of noise. I don't know what happened, so I have to re-record my voice over the project to explain every step. Please accept my apologies if there are some unsynced scene with the audio. Now let's have a look at the components list. As you can see here, we have the list here on the disk, and we have actually the port here. The two 10 kilo resistors, the two resistors. We have two capacitors of 30 picofarads, so these are 30. So these are 30 picofarads. After that, we have 104. 40, so that's 104. That means 40. That's 100,000 picofarad or 100 nano. Then we have a 10 microfarad electrolyte capacitor, which has a polarity. The other three has no polarity, but this is important that the negative is shorter and the positive is longer. Then we have 1 kilo ohm resistor in an array. There are 8 of those together. And then we have one common pen and then 8 pens. It's written 102, so 1 and 0 is 10, and then 4 is number of 0. The 2 is number of 0. Then we have a 12 megahertz crystal oscillator. 12 mega is written on it, and then we have 8550 transistor here. This is a transistor with 3 pins. After that, we have two 6x6x5 switches. So these are the two switches. These are the push button switch. As you can see here, when we push it, it just functions. It can be pushed. And then we have 20 pin IC socket. This is the IC socket that you can solder here, and then this is the actual IC or microcontroller, so we can insert it later. When you solder it, actually the safe way to solder without any damage to the actual IC, because the heat or whatever dissipation of heat will not damage it. And this is the actual IC, the next item, and then unit MCU. Then we have a buzzer, 5-volt buzzer or speaker, which is for alarm. And after that, we have 7-segment display module, as you can see it here. So let me rotate it. Now let me just move the camera. After that, on the rest, we have a 2-pin terminal block. The terminal, which this goes on the board, so we can connect the power wires here to power the clock. After that, we have a 52 by 42 millimeter PC board, printed circuit board, and then of course this paper version of portless and schematic. Now this is the schematic diagram. We have 5 volts here. All these 5 volts are everywhere. They are referring to the same point, so we don't put a lot of wire. And then G and D at the bottom refers to these are ground or negative sign. The battery will be connected to here and here, or from this point, from the terminal. This goes to the 5 volts, and this 5 is connected to all points that you see 5 volt is written, and wherever you see ground, the ground is also connected. Then we have a 7-segment display. We'll be showing the actual clock from 9 to 12. All those pins will be connected to the array of 1 kilo ohm resistors. From 5 volts it goes to resistors, and from each resistor the limiting current, and they are connected to the 7-segment display. And if you look at this here, we have 7 elements in each display. A, B, C, D, E, F, G it's called, and these will be connected accordingly. So internally it will be connected, the first one and the second one, in a way which is called multiplexing, and one instance of time, one digit will be on, the rest will be off, because otherwise it requires a lot of wires. But this is a smart way, and then one of them will be on and then the rest will be off, and at a very high frequency it will be turned on off, because our eyes can see up to 24 hertz a second. If something flickers faster than that, we will not see it. So that's why the movie in the cinema is also 24 frames per second. So each segment will be on and off at a very high frequency, maybe a kilohertz or more, so your eyes will not detecting it. So sequentially will be on, and so we see them all on. And then we have 12 megahertz crystal will generate the oscillation, and then the oscillation will be divided so many times with the microcontroller until we get 1 hertz, and then the clock will run. We have 2 switches, and S2 or as this that we set the clock. You see the other pins are P1, P2, P3 are internally connected. So to make the diagram easy, let's get started with soldering the components. So with the parts from the 2 resistors we can start. The resistors don't have polarity, so whichever way you prefer you can put it. So according to the diagram, we have R1 and we have R2. The two are the 10 kilo ohm. So we see here R1, and then so R1 is here, R2 is there. Let me just put the pins, and also just insert the other pin here from this hole, and then the soldering will happen on this side. So just push it and make sure that both sides have equal length. So once they're inserted, just bend the pins so it doesn't fall. We will put all the pins, we will insert as much as parts we have, and then we will solder them. So now let's insert R2. Let's insert it here the same way, so they have no polarity or direction. Whichever way you want, just insert it, and then from this side just bend it so it makes your life easy. We can cut them now, but that's if bother. But so let's see how it works. Then we have a 3 picofarad capacitor. So let me put under magnifier to show you. It shows, you can see here 30, that is 30 picofarad. That's a 30 picofarad. So we have C2 and C3, these two 30 picofarad. So C2 is here, I'm just inserting it. Now here we cannot pull it fully because this is ceramic capacitors and they will break. So we have to be gentle with them. as normally as possible. If they go, just push them, but not force them. And also let's take the other one, the C3. C3 is also here. It's on the board, 30 picofarad. Just I'm not forcing it, I'm just putting it as much as it goes. That's fine. The 100 nanofarad. So this capacitor will be inserted. Let me see the location. C4 is here, as you can see. 104 is written. Just insert it and then bend. So that's also inserted. It's done. Then let's get the capacitor. The longer pin is a positive. This capacitor is C1, so mentioned here, and you can see it's also marked as positive on the other side. So the negative, you see, mentioned positive with a long one. Just insert the positive and short at this side. This can be, however, inserted fully. It will sit on the board, so you see there is totally flat and no space in between it. And then we have the resistor. This will have a dot at the end, so here is a dot, so that is a common pin. So the common pin, very important. How it works is all of these other pins are connected on the top and connected to the left pin. So let me see. That's PR1, so 1 kilo ohm, and here, and you see the corners, they put a line to show. Because this cannot be bent, I'll just leave it to the end. Then the crystal, the quartz is 12 megahertz. It doesn't have any polarity, and it will be inserted fully. So just bend the wires, the pins. It's also done. Then we have a transistor, 8550 transistor which drives the audio. As you can see here, is one side is flat, the other side is curved. If I hold this, you see this side is flat and this side is curved. It must match the curve and flat. So let me just insert it. So this cannot be pushed fully because the pins will break if you push. So the legs are apart, so we cannot push it more. So just bend the legs so we can solder it. I just put the other pin the other way. Let's just solder these and clear it, and then we put the other parts, the other components next. So I'm just using this hand. This is called third hand, so it's just holding it for me to make life easy for soldering. Here is my solder wire and a soldering iron. I have to clear it on the sponge, which is a little wet. And as you can see, it's now cleaned, the tip of this soldering iron. So pull enough solder and then start with any pin that you want. So we put the solder on one side and the soldering iron on the other side. As soon as the solder reaches the solder pin, it will be melted and will fill up the hole. So that was enough. So I will do it for the next pin. So I'm just pushing the pen so I can solder the other piece, and so forth. So we'll continue with the same method to solder everything. I will solder everything and will show you. So I just finished it and I cut them. I forgot to record. So the same way, they just clip the pins. So this is all done with all those parts. Let me just green this area. Then we can do the switches. So the switches have 4 legs. They have 4 legs. So we have to make sure if you hold the switch, on one side the 2 pins are far apart, and if you look on this side is closer. These are far apart. So just the far apart should be on the edge. Just push those buttons, push buttons, and then solder them. Now let's put this one. The dot is on that side. So make sure pay to that sign is for the dot, insert it. And then at the bottom it should hold this. So if I put it, it will fall. So I will put something underneath. Just solder one pin, and then you can solder the rest as long as it holds itself. That would be fine. So that pin was done. Now I'm going to use this third hand holder, so hold the board for me, so I can just solder it. You don't have to hold the soldering iron for long, because it will burn the component. So make sure that as soon as it melts, remove the soldering iron. So that is also done. Now let's put the buzzer. So buzzer also has a plus sign at the top, and plus pen, the longer pin is also plus. So for the positive, make sure that insert it in the right way, because it's a big, the largest piece so far. Just put the board on the ground, it supports itself, and then solder it. These holes are a little larger, so put enough solder, and then clip the wires for the buzzer. Now put the IC socket. IC socket at the direction. You see this notch here, the curved area. So this is the same, and the actual IC or microcontroller also has. So first we will insert the socket. Okay, it seems some of the pins are bent, so let's straighten them before inserting it. As you can see here, these pins are bent, so let me just straighten them, and then they are straight, and then let's insert it. I have to bring it closer so I can see it. Now one of the pin is not straight, so I'm just pushing it with a little on the left side, so it's inserted now. So the socket now, so now I will use the holder, so it with a crocodile clip will hold it for me, and then I'm going to solder this all. So one side on the left, and then one on the other side. So diagonally just solder those first, so the socket is in place, and then after that just start soldering them. Now let's put the power terminal. Make sure the metal is outside like this. We cannot insert it like that, so it will be wrong one. So insert it this way, and then because it's the largest piece, we can just put it on the ground. I'm sorry it is out of the view, but I just soldered it here. And once that's done, so there is a space here. So one pin is already soldered, so I'm just holding it, and it's flat, fully inserted, and then solder the others. Now let's insert the 7-segment display. Inserting it, which make sure that these, so let's solder them. So when I inserted, the decimal point on the 7 segment display was at the bottom towards the switches. So that is how you know if you're inserting it in the right way. So very important to pay attention to that. So you can see that decimal points are lower. So the only thing that is left is the actual microcontroller or IC. So there are some bent pins, so let's just straighten them. Make sure that they are all straight so it can be inserted easily. So it's good. Now let's just try it in the same right direction, paying attention to the notch. You see this notch here? So it should match the socket. And all the person good, just press it, so it will be inserted. So the kit assembly is now complete. So now I'm powering it 5 volt through USB through my Arduino, and we have 5 volts on ground. The yellow is ground and the 5 volt is the green. Now I'm connecting it to my multimeter. As you can see, 5 volts shows 5 volts. Positive is the green, because if you reverse the polarity, it will kill the clock. So using a screwdriver, just open those screws, and then so the green is positive, and it's also positive labeled on the right side. If I press it, it will just go. You don't need to tighten it. Maybe it's loose, but for test purpose it works. So I inserted the negative as well. It shows 12:59. So the clock is on. By default, it starts with 12:59. So the second is also blinking. So that's good. We have so much light, but it's very nice and bright. So we have now I've turned off all lights. So now I've turned off all lights, and let's see how we can use it. So now let's power it up again. 12:59. So as you can see, it starts at 12:59. So we have 2 alarms, alarm 1 and alarm 2, and we can this is S1 and this is S2. When class is displayed, when press S2, it shows the minute on the, and then the second is displayed. Press it again, it goes back to hour and minute. 59 is a minute. Now the clock turned to 13, so every hour it just makes beep to tell you the clock has switched to the next hour. So press this S1. If you press and hold it for longer, it shows A. So this is the hour. So you can change the hour with S2 with pressing the other button. So we can go, it goes up to 24 and then comes back to 01. So, and then if you press the second one, this becomes B, and then that's for minutes. We can change the minute. Press it again, it becomes C. So this is alarm 1 on and off. So now we can press it off, make it off, and press it and make it on. If we set this off, and so if we, so from here we can set it on and off. So let's set it on and press this button, and now it's D. So that alarm 2 is on, and we can set it on or off the same way, and then press this and it will be E. The hour, this is the hour is alarm 1. This is hours for the alarm 1, and then press this. F is the alarm 1 minute. So this is minute, press this again. This is alarm 2, G, which is on and off. And then press this again, it's alarm 2 hour. H is alarm 2 hours. We can change it. And then we press, and then press this button again. This is I, the alarm 2 minutes. So this way you can set, and then press it again, it will go back to hour. Now it's 6 6 a.m. 6:05, and this is 26 seconds. So let's make it at 6 o'clock and 6 minutes. So press this and hold, and A. I'm pressing it B, and then C. So alarm 1, that's on. Now let's go alarm 1 hour. Let me change it to 6, and then press this again to go to minute. Let me make it 6. So now 6:06. So let's press this and go to clock. So now 6:05. This is my at 6:06 alarm will run. As you can see here now. So that is the alarm. So when I press it, you can stop the alarm. So this is the manual. The manual will be posted at robojax.com. The link for that is at the bottom of this description of this video. But if you want to power this clock other ways, just go to ebay.com and then search for 5 volts power adapter, and you can see here it shows at 99 cents. Then you plug it in the wall and you get 5 volts, and cut it and connect it to the board. Or you can get it from any USB, plug it into your computer, cut the wire, and using the multimeter find out the 2 wires that are giving you 5 volts positive and negative, and connect it to the digital clock. Please thumb up the video, and thank you for watching. 1, and then press this. F is the alarm 1 minute, and then press this again. G, H, the alarm 2, on or off.